The driving section was fairly simple. It was just a motor geared for torque attached to a wheel. Now here it is mirrored over to the other side on that big plate. The line tracking sensors would be able to navigate the path, and in this next photo you'll see them in what was going to be later the back of the robot. I originally had this thing flipped, but I put an omni wheel up in front. The idea behind the claw was to give it a rotating base, two joints, and of course the claw. This was to give it a very dynamic range of movement. That later turned out to be more trouble than it's worth. But anyway, here's the lower portion, the actual claw itself, and then now here's where the two joints are meeting together. Now that's both going to be powered by motors, not servos. I'm going to have potentiometers on there to sense the range of movement, where it is in that, and then make decisions accordingly. Now here's the assembly coming together for the full claw. And I think it actually turned out pretty well. The idea was solid. It was just a lot more complicated than it had to be. So now we've got the robot actually coming together, starting to look like a can recycling robot. It's got the claw, it's got the driving, it's got the bins. It was a lot bigger than it had to be. It was a lot more complicated than it had to be, but in the end, it did its job. And here I'm just testing and demonstrating the range of movement of the claw to make sure it can actually put the can from the ground into each of the bins, because if it can't do that, something's got to change, but it looks like it can do that just fine. So these were some of the changes I was talking about. It was big, it was heavy, so I had to put in some physical limitations to keep the claw from driving itself over. So now here's the finished claw, and then there is the can sensor. I didn't really document the code for these earlier tests, but all in all, I think it went pretty well. This is more or less a carbon copy of the last robot I built, which was just built to navigate a white on black on white. This is black, white, black track, so not much different. The next step was to get the ultrasonic sensor and the can line sensor to work together to be able to sort the cans into the respective bins. Because I created my own functions, this is what my final loop looked like. These were the two most important functions which were used to read and store sensor data. I actually created several functions for movement. These were the ones that were called on by the overall movement function, and then this was the overall movement function that was used in the loop. Similarly, the recycling function used many smaller functions in order to do its job, and the resulting code is relatively easy to write, debug, solve, and fix. I wasn't able to record this all in one take because the potentiometer I used to track the rotation of the base kept getting knocked out of place, so that it was oftentimes knocking the can over or missing the can entirely, and that got very frustrating. I spent hours trying to fix it, but ultimately it was just a problem with the hardware that I wasn't able to solve. Since that footage was somewhat staged, I figured I'd include my best attempt at completing the course all in one try. This actually went really, really well, but in the end, you'll see why I kind of had to leave it out. Because yes, even this attempt had a couple bloopers.